Okay, so this is take number 2 on this logistic thing here. So I'm redoing this because I messed it up in class, and then it messed up again after I did it. So this is attempt number 3. So it was the fruit fly population here, which had a carrying capacity 1 plus, put an A there, e to the negative bt. All right. And the initial value, which was told to us, is 4. And after 5 time periods, there are 23 of the little fruit flies. All right, here we go. So now we're going to go ahead and work this out. Now it tells us that the carrying capacity is 230, so I'm going to put that there. 1 plus. I don't know what A is and I don't know what B is, so I need to find those. So the first thing I'm going to do is find A. So 230. So let's see. We're going to find A. We know the initial value is 4. So I'm going to put that in for f of t. I'm going to put 230 there. 1 plus A, E, negative B. The time is 0. And that's huge because now that becomes e to the 0, which becomes a 1. And that makes things a lot easier because that's all we got down there. So then we do this cross multiplication. Divide by 4. So we get 57.5. But now I know what A is. So I can go back to my fruit fly population thing. I think it was, I'm going to use F for fruit flies. 230, 1 plus, 56.5, E negative B, T. All right. So once we have that, we got to find B. Okay, so then to find B, what we'll do is we use at time 5, we add 23 flies. And you can pick any time you want. I just happen to pick 5. All right, but off your chart, you can pick any time, any time. All right, so I'm going to put 23 for my f of t. I'm going to put 23 there. 1 plus 56.5 e to negative b, and my time is 5. All right. So what I'm going to do here is do a little cross multiplication again. Can make this look a little better here. Divide by 23, divide by 23. Okay, subtract that 1 out of there. And I got it down to this, right? So here I am back at this one situation where I could use a definition. I could use the log of both sides, right? I can even break this down more, which I think I will. So the more I carry this out, the more accurate it's going to be. Now I'm ready. All right, so I think what I'm just going to do here is take the log of both sides. So this is going to pop out in front. Ooh, what happened there? There we go. And I need a log of that stuff. And I think I'm going to just bring it out just a little bit. Alright, divide that by 5, negative. And I should be in good shape here. There we go. So now once I know what b is, I can do anything I want because I've got my equation here. I can find the number of fruit flies that there are at any time. I can graph it if I want to look at it. Right? I can do anything that I want. There it is. So that's basically what you're going to do. All right, on the project thing. Okay. All right. Now, I wanted to show you some stuff in Desmos, right? So let me go to Desmos. And I think I'm signed in. Let me log in here. No, I don't want to do that. All right. So I'm logged in here. Let me go get my one that I have here. This was the rumor graph that I was talking about in class. All right. I'm going to find an equation for this because it would be hard for me. I mean, I could do it, but I don't know what the carrying capacity is. I could take a guess, right, and walk through it. But you know what? We're going to do it this way. So I'm going to go y1. So this is how you find your regression. Equals carrying capacity. I don't know what that is, so I'm going to put a C there. Parentheses. Oops. Divided by 1 plus. I need an A, E, and I want to make sure that I put a times there just so that it knows that. To the, make sure I put a parenthesis there. I don't know what B is. I know this is an X, and I know it has to be a 1. And I know that can't be a tilde because, or equals, it has to be a tilde. There we go. Now we got a pretty fit. So it tells me everything. It tells me what the carrying capacity is right down here. It's about 55,000. Tells me what A is, 495. Tells me what B is, negative 0.101. Got a nice fit. There it is. All right, so that's kind of what you'll do. You'll get a better fit for your equation. Still might not be perfect, but it's going to be better than probably guessing and checking in this case. So that's how you do that on Desmos. Yeah, there you go. Good luck.